right, this next problem is another u substitution, but originally I had it as an indefinite integral, and I want to practice with a definite integral. So I actually changed this from the type. We're going to go ahead and integrate from 1 to 3. So imagine that what's written in red is actually part of the problem. So we want to integrate from 1 to 3 the function the natural log of x over 2x dx. So first thing we need to do is we need to find an appropriate u substitution. So even though I don't really need to rewrite this in any way, I personally always write it down because I like things to be in a certain format. Okay, now, unfortunately we don't really have any terms inside anything. But there was another trick that we learned in the u substitution section, and that was, if you have a natural log term, you typically are going to let your u be the natural log term. So if u is the natural log of x, what's du going to be? Well, it's going to be the derivative of the natural log, which is 1 over x dx. The other thing we learned is that if we have a definite integral, we need to change the bounds. And what this does is it allows us to rewrite the entire function in terms of u and not resubstitute. We're going to not get any x's at the end. Instead, we're going to change the bounds to be what are called u bounds instead of x bounds. And then we'll have everything the way we need it. So let's look at our current bounds. Our current bounds are what we call x bounds. Because first of all, if our value is 1, that means x is 1. So if x is 1, if our value is 3, that means x is 3. Okay, so if x is equal to 1, then, well, we're going to use, let me see if it'll let me highlight. It won't let me highlight it. So I'll just circle it in a fancy color. Ooh, green. Okay, so we're going to find what u is. And we already know that u is the natural log of x. So if x is 1, then u is going to be the natural log of 1. And actually, we know what the natural log of 1 is. It's 0. On the other hand, if x is 3, then u is going to be the natural log of 3. And unfortunately, that does not simplify. Yeah, that's okay. So let's substitute. If we substitute, my integral, it did originally start with the value 1. But if I switch everything to u, well, I know if x is 1, u is 0. So I'm going to start at 0. Originally, I went all the way up to x equals 3. But I know if x is 3, then u is the natural log of 3. I know it looks terrible, but those are our bounds. Now what about the problem? Well, we have a 2 in the denominator that didn't show up anywhere else, so it's going to stay there. So I'm going to still have a 1/2. The 2 is going to be in the denominator. Now the natural log became the u value, and the 1 over x dx is my du value. So I'm really integrating from 0 to the natural log of 3 of 1/2 u du. All right, well, what's that? Well, now we're going to use the fundamental theorem of calculus. All right, because we have a definite integral. So the fundamental theorem of calculus says, find your antiderivative. It's going to be 1/2 u squared times 1/2. Instead of the plus c, we are going to evaluate this from our lower bound of 0 to the natural log of 3. So this is really 1/4 u squared, evaluated from the natural log of 3, or from 0 to the natural log of 3. And the fundamental theorem of calculus says plug in your first bound. So I have 1/4 times the natural log of 3 all squared, and subtract your lower bound, which would be 1/4 times 0 squared. Well, the 1/4 times 0 squared is just 0, so I don't need that. That's just going to be 0. So my final answer is actually going to be 1/4 times the natural log of 3 all squared.